Next, we're going to talk about the sample part of this diagram that we've been discussing this semester. Now, there's a number of different ways to take a sample. In fact, at many universities, there will be an actual whole course on it. We're going to focus on one particular way, which is the one that's most often used, and that is simply taking a random sample. In the end, the process isn't too difficult, but in any introductory statistics course, you should have at least a little bit of a background about how to actually take the sample, since in statistics, that's what we tend to focus on when we end up doing inference, which will end up being a main part of our course. Okay, so a random sample is simply a sample from the population where every item has an equal probability of being included in the sample itself. The easiest way to take a random sample is to, let's say, number all items that are in the population from 1 to capital N, and then use a computer software package to do the sampling for you. In other words, use R with the sample function to take the random sample. So here's real briefly how it works. Suppose we have a very small population. Let's say it has capital N equal 20 different items in it. And our sample size is 10 that we want. So we number all items from 1 to 20. And what we can do in R is set particular values for capital N and lowercase n. Then we set a C so that we can reproduce our results if needed. And simply, we use the sample function where we say, well, we want to sample from the items of 1 to capital N. How many items do I want to sample? That's where little n comes in, are 20. So the very first item in our sample is 17. The second item that appears in our sample is 14. So now with that then, of course, then you would need to get the actual, let's say, numerical value for that item. So if we're talking about, let's say, students, if we're trying to sample from a population of students, student number 1 would be 17, and maybe we want their GPA, so we get their corresponding GPA. Second student would be student number 14. We go ahead and get their corresponding GPA. Now, well, what if I use a different C number? Well, and most likely I will get a totally different sample. So you can see why setting a C number is very important so that you can reproduce your results at a later time if needed. Now let's make this a little bit more realistic. Suppose we have a college that had 25,000 students in it. We were interested in, let's say, estimating the average GPA of all students, where the only way we could get at these GPAs is if we ask each student, what is your GPA? And suppose we want to take a sample size 100 from these students. So what we would do, again, is we number each of the students from 1 to 25,000. And we set then what our sample size is. We set a C, and then we use the sample function just like what we did before. So the very first student in our sample is student number 19,628. Now, in the end, do you have to actually number all the students from 1 to 25,000? No. If somehow you could actually have a record of, let's say, maybe their names, then what you could do is create a vector called Y and put all their names in that vector. And then that Y goes right in here for the X argument of sample. Of course, though, you would need to have all their names, and that might be difficult. So that's why, at least in this introductory example here, it's convenient to simply put numbers 1 through 25,000. In an alternative case, maybe, for example, you have some kind of student ID number. If you could fit somehow all those student ID numbers into this vector of Y, again, you could use that with the sample function. So should you use the same C number every time? So suppose I want to go sample from one university. Should I go use the same C number now when I want to sample from another university? And the answer is no. The reason being is because that means that there is some kind of interconnection between your different samples. So just simply choose a C number. It's not a different C number. It's not very hard to do. So then you might be saying, well, how do I actually choose a C number? Well, In a classroom environment such as this, or a class environment such as this, what I simply do is I put my fingers on the keyboard and I just simply press down on the keys about the same time and numbers will come out. That's how I choose a C number. What that's trying to do is emulate is choosing that C number randomly. Obviously that's not perfect, but I'm just doing it for a classroom situation like this. However, now in other situations where I do want to make sure that I select a C number in a good way, what one can do is to simulate a sample from a uniform probability distribution. Now with these uniform probability distributions, essentially all possible values have an equally likely possibility of being chosen. So if I looked at a uniform distribution like this, let's say from 0 to 1 for my y, here's what my uniform probability distribution will look like. And if I tell R, hey, choose a number corresponding to a population that's characterized by a uniform probability distribution, then maybe I might get the corresponding number that would be right there, or maybe right there, and so on. And then I can use that number as part of my seed. So what I can do is use the RUnif function. Let's say I want 5 different seed numbers, where the maximum possible seed number is 0. I'm sorry, the minimum possible seed number is 0. Maximum is 1. And so what I'm going to do then, after I run this code in R, I'm going to take all the numbers to the right of decimal place and use that as my seed number. Now, of course, every time that I run this set of code, I'm going to get a different set of seed numbers because I am not setting a seed actually to do the RUnif part there. And that's okay in this particular situation. I just need some way of choosing a random number to use as my seed. Okay, so that's a real brief introduction to how to actually take a random sample.